Okay, so some disclaimers. First of all, this is a survey. This is not deep digging to the subject. This is just light talk. This survey is as light as possible because I intentionally don't want to dig deep here. I hate surveys probably because I have very little skill to prepare them. Anyway, not everything I will talk today I have tried, even in the test. Some of these protocols I didn't use at all, just read about them. And this is a reason for this, you will understand it later. Most of the information I'm giving you today is Captain Obvious kind of information, and most of them is a reading of the manuals loudly. Okay, could you please raise your hand who is Golang developer right now? Almost everyone. Who is senior Golang developer? Okay. Who is building network IPs on day-to-day basis? A lot. Okay, let's go. Some theory. What's the network API from the programming language? I guess I have lost some slide. Anyway, what's the programming language? What the API looks like from the programming language point of view. It's some glue code, some tools around this protocol, linters, code generators, something like this, and some documentation about this protocol. What is network IP itself? Sorry, I've lost the slide. Okay, what's the API, network API in general? It is, first of all, it is a communication protocol like TCP or HTTP or WebSocket or UDP or something. It is some marshalling, unmarshalling tools. Like JSON or message pack or protobuf or something, because we couldn't transfer binary information from one computer to another. They have to encode it somehow. You probably know what is this about. And the first thing I forgot. Anyway, so this was some theory. I'm very sorry for this mess, because I did have prepared with speech in Russian, and this was a surprise for me to speak in English. So I'm not prepared. Anyway, some theory. For the moment, we have just two paradigms in hand. We have CRUD, C-R-U-D, create, read, update, and delete. And this is a good paradigm, except this is not enough for most of our modern tasks. It was good enough then it was published in beginning of 2000. In 2002 exactly it was published. Anyway, it was good. It was a good idea, but for today's tasks, we have some state. On most of the objects we have some state, and this REST paradigm decline the state on the server side. All the state must be on the client side, and this is why it is not good enough. And another paradigm is much more older. It came from 60s of 20th century, and it was only one paradigm in before REST was published, and it is the best thing we know about this RPC paradigm. It is flexible, but it is too flexible. Sometimes, if you are a team lead, you especially know what what is too flexible, because your people writing some code you could not review because you couldn't understand it. That's true about RPC. Oh yeah, this is a lost slide. Finally. Okay, network API is a call convention. How we will call, do the call, it is marshalling and unmarshalling and transport, the protocol we are using to pass information from other side to another and back. On client side, we usually have not Go program. For the modern network APIs, it is mostly network browser. So JavaScript or some TrueScript or something like this. This is, but for inter-cluster communication, to communicate between our services, we usually have Go on other side. And this is important. I will speak about this a little later. So, first of all, who is using open API on daily basis? Nobody. Okay. So, what is Open API? Open API is a it is a REST paradigm in all its glory. Open API, formerly known as Swagger, I don't know how to pronounce it, sorry. Anyway, it was built for REST API, and it is still the best tool for REST API. What should I say? From the technical point of view, it is request response call convention. It is JSON marshalling, unmarshalling. It is HTTP 1.1 as a transport protocol. It is a special domain-specific language to describe your API, and it is code gen. It is invented to be used with code generation, or at least with doc generation. What does this mean? Two ways to use your Swagger file. First of all, you can write your code. You can place some special comments around your code, named annotations, and then you can generate the documentation based on these with these special comments. What's wrong with this thing? Most of the time I saw this thing in action. I saw these comments were not exactly describing exactly the same situation as was described in code. So all the time I was working this OpenIP used this way. It was necessary for me to read the code to understand what's going on. Other way to use Swagger file is to write the whole protocol in JSON or YAML file, and then to generate your server-side code and your client-side code from this spec. That means you have this spec, and this is a final source for your code, your API calls, and your documentation. That's extremely important when you're dealing with network protocols, especially with public available for network protocols. Once we spent a week debugging the problem, and finally we found some of our programmers have changed the API call, have changed the field type from float to integer. And we stopped accepting most of our requests from clients, and we didn't know this until we get this debugger to the prod. Because he have changed the code, he have changed the test for this code, but he didn't change the doc. So it was quite difficult to find what's wrong. So there is more than one way to use it, but only one is true. You write your spec, you generate your code, and you use it. Other way is a road to hell. Tools for Go. The most mature tool is Go Swagger. It is only version 2 of OpenAPI supported in Go Swagger, and unfortunately, code quality in Go, which Go Swagger generates, is not perfect. For example, then you write your regexp to validate your input. Go Swagger is compiling these regexps every time for every request coming. This is not necessary because this regexp is known before on program start, so you definitely can compile it once and then use the compiled version. But anyway, another option to use Swagger with Go is OAPI CodeGen. I am intentionally not providing you the links to these tools because then you will Google for them. You will know much more than I am speaking today about, so it will be very good for you to Google for them, not to just read the links and go to them. Anyway, it is OpenAPI version 3, which is much better than version 2 in any matter, in any case. For example, in the API version 2, you have to, if you have some cook-based authentication, you have to parse your cook header yourself. And in version 2, you can specify which header is used and which format of cook is used. So, which cook is used for authentication and which format this cook have. So, the only problem with OAPI CodeGen is the spec of OpenAPI version 3 is not fully implemented. So some things like one of or many of is not implemented properly, it is not type safe. So I am personally using Go Swagger when I need REST and Go. Other tools. Originally, Swagger CodeGen written in Java, as far as I know. So to generate not the Go code, with Go Swagger, you can generate Go server code and client code, but no other languages. So if you need some JS client, you will have to use original Swagger CodeGen. And Swagger editor is a very important tool for Swagger developers. What Swagger editor can provide you? It can provide you a page with doc to your OpenAPI, and this is important, with some examples you can run from this very page. So you can for each the call described in your Swagger file, you can from the Swagger editor you can press the button and send the request and see the answer. This is quite important. Especially it is good for public APIs. It is public anyway, so it is no problem to pass it through the Swagger editor website. So this is very handy. You don't need to run your own Swagger editor. You can use the cloud one. So OpenAPI. If you choose the protocol, this is the answer to how to choose. If you use the protocol, this is a pros to to Swagger. It's a standard. First of all, it is implementation of the first paradigm came after Corba and SOAP. So it is most major, and it looks like about 30% of network APIs built on top of this open API, formerly known as Swagger. So it is a standard. So you will easily find programmers who will read this your Swagger, who will write your Swaggers, and we will find a lot of tools and a lot of answers on Stack Overflow. So that's an idea. Native support in browser because of JSON. Because of JSON and HTTP 1.1, it is natively supported in browsers. So even you don't have a client for your platform on browser, you will be able to communicate with OpenIP-based server. And because of this documentation is generated from the same source as code was generated, documentation is always perfect. Okay, it is not perfect. Not completely perfect, but if you write your Swagger file and then you generate to every and you finally got your working API, all the things you did will be presented in the documentation, and this is extremely handy. Controversial. As you probably know, JSON is slow in Go. Even with some statically generated marshallers and marshallers, JSON is slow with Go because it is producing a lot of garbage, and that's a problem. No streams. Nor version 1, nor version 2, nor version 3 of OpenAPI is not including any kind of streams, not from client to server, not from server to client. For some areas, it is a problem. It is HTTP bonded. As all the REST protocol it is HTTP bonded. For example, HTTP errors are used to pass the protocol errors. So this is you cannot just get your open API and put it on top of a WebSocket or even HTTP/2. It is still HTTP bonded. And probably the most problematic thing with OpenAPI is CRUD is tough, really tough, because actually nobody, including me, understands the CRUD concept fully. And then your people writing these open APIs, they are writing something which they think is CRUD, but it is not CRUD. And it's a good way to shoot you in the head, finally. And OpenAPI have no tools to keep your team on the CRUD way. So, how to survive? Write your spec for the protocol as strict as possible. Then you provide the input field, integer, for example. You can specify a lot of things about this. For example, minimum, maximum, and so on. So do it for all the fields. For the fields, all the fields it is possible for, specify the regexp. So all the incorrect requests will be declined on the protocol day. So that means your handle for OpenAPI method will get your data ready to be processed, not half prepared. As I said before, CRUD stuff. It is very likely you will not be able to implement the things you need with CRUD paradigm, so you will get to the RPC paradigm and the OpenAPI will not stop it from this. So write your own RPC standard. On top of this paradigm, you have to write some small documents. Our small documents is 7 pages long, about how to write your RPC API on top of OpenAPI, which is not invented to be used with RPC. And document it, and this is important. And again, always write your protocol in YAML or JSON, and generate code from this spec. Don't use it another way. Okay, said it again. Okay, next. Who is using grpc on daily basis? Okay, not so much. So from technical point of view, it is very interesting. It is request and response. It is push, so you can have stream from server to client, and server on its own initiative can send data to the client. And you have, other way around, push is from client. You can have stream from client to server, and you can have events, so you can send from server to client. Marshaller and Marshaller's protobuf. Protocol is HTTP 2. This is important. grpc is always HTTP 2. And it is code gen, and no other way to use it. Very good. Code again, named, okay, so next slide. So your protocol is described in proto files, and these proto files looks like self-documented. Actually, it is not 100% true, not the same way as Swagger was self-documented. So you have to write some comments to proto files, and this is why I don't really like protobuf, but anyway, it is good. And in compared to JSON, it is binary, and it is smaller and probably faster. I didn't test it, so I think it is faster, but I don't know exactly. This is a picture. This is how grpc communications described on official site of grpc. It is useless, as you can see. Tools. The only tool you have to use is proto compiler, proto-C. This is a official tools. I don't know, I don't remember which language is written for, but definitely not Go. And to this proto-C, you will see some plugins to generate different kind of languages and protocols and so on and so on. For example, you have to use a special plugin to proto-C to generate Go files. But anyway, it is your entrance to the grpc world. Other tools. Uber, the not really profitable company, provide us a very important tool, the number of things, linters and checkers and formatters. Proto tool is what you must have when you work with proto files and so with grpc protocol. grpc web is a gateway between browser and your grpc server. The problem is you cannot use grpc directly from browser. Just because you have no ability to work with HTTP2 directly. So that's a problem. You will have to use some converters And this is a server-side converter, which is dynamically getting REST requests and converting them to gRPC requests and then passing them to the backend. In this very room, we have a human named Johan who wrote a good article about this. Johan, could you please raise your hand? This is the author of the very good article in the internet about this gRPC web thing. And so if you have questions about this, please address them to him. He's speaking here in 2 hours, as far as I know. So, and another way to handle your gRPC from browser is gRPC gateway, which is a tool which can build your reverse proxy from REST to gRPC and generate the code. So this is not runtime, this is a statically created thing. For myself, I don't really understand why to write your server protocol based on gRPC and then convert it to REST. Let's use REST in the first place. So, what's good about gRPC? It's a standard. It's a client server and server client and bidirectional streams. So you can have your client calling server, providing the stream, and in Go you will have a channel to write to, and you can get back from the call another channel, which you have to read to get messages from the server. Bidirectional streams are very handy when you write your service-to-service communication protocol. And ecosystem of the gRPC is very rich and very powerful. So it's a good choice. No, controversial. Streams, no native streams support in browsers. So the most important thing we are expecting from streams is not available in browser. Most important thing we are expecting from the client is not available for browsers. So 90% of our tasks is not covered, are not covered. The only thing you can specify in protofile is type of the field. You could not, in Swagger, you can specify a lot of validators for the field. In gRPC, you couldn't. So all the validators you have to write yourself by your hand. It is HTTP2 bonded, and on some systems, HTTP2 is still not very well supported. For example, on some reverse proxy you have on the border of your cluster, if HTTP2 is not supported on this proxy server, you will not get HTTP2 inside of your cluster, so it would not work. But HTTP2 is something about TLS at first. And you can get rid of TLS using a custom dialer with gRPC services. So you can, your servers and your cluster can communicate without TLS, which is, you know, is not very cheap. How to survive? Proto tool from Uber. Use it. This will help a lot. Use your Go generate. Most of the time I saw gRPC protocol, I saw the make file near this protocol. Don't use make. Go generate is okay. It's not so good, 10 minutes. Okay, anyway, don't provide all the parameters for generator in the proto-C command line. Use proto-C config file. And this is important, use option go package inside of your proto file, because in this case it is very handy then you put your proto files in different tiers. Something like this. Okay. So, could you please raise your hand who is using GraphQL on daily basis? Great. 2, not 1, 2. Okay, I didn't use it, and I didn't use it for the reason, and I will explain why I didn't use it yet. GraphQL is designed to get us a freedom, and this is very important idea. This is not a freedom to write everything we want to write. It is a freedom to deploy client separately from the servers. With all the traditional protocols like OpenAPI or grpc or the things I will talk later. Two of the things I will talk later. We have no freedom. We are changing the protocol. We have to deploy client and server in sync. This is not true about GraphQL. You can write GraphQL the way you can deploy your clients, and then you can deploy your servers. Or you can deploy your servers and test them, and then you can deploy your clients. This is good, and this is what we want, and this is what we call freedom, and this is a biggest problem of GraphQL. The main idea behind GraphQL is to allow client to request any data in any order which backend can provide. How they get to this situation? This is some picture from internet about describing how the GraphQL works. So we have no pointer. Okay, no problem. Okay, we have client, we have GraphQL executive engine, we have query parser, we have query validator, which checking if this query conforms to the schema backend supports. We have resolver for the fields in this query, and we have these resolvers are talking to the real world, to the database or to a traditional API. Anyway, resolver is a place where we can get data. One other thing came to the picture. Then we are building the complicated system. Between resolver and the real world, we will put data loader. There was a joke in Russian about it. We call it loader. Loader is lazy, but it is no joke in English, so okay. Anyway, data loader. There's some layer which can provide you cache of the real data, batching the requests to the real world, and some other things. So in the real complicated application with GraphQL, you will have another component. On this picture, you will have data loader here. That's the big picture of GraphQL. So if just 2 people in this room know what is this, so no, I don't know. Use it. So. As far as we can understand from the paradigm, it is oriented for front end. It is request response, no streams. It is JSON as marshaller and marshaller. It is HTTP 1.1. It is domain specific language, sort of, and it is code gen optionally, optional code gen. This is not this one is not true. This state is not true because, as a matter of fact, GraphQL doesn't tell us, doesn't say anything about protocol or marshaller. That's agnostic to such things. Okay, To build GraphQL servers, you can use GraphQL Go. It's run with runtime server schema parser, or JQLGen. It will generate your server with from your GraphQL schema. This is about data loader I was talking before. Look, no other protocol specify anything like data loader but GraphQL. So this is a thing we don't have. We can use it in other protocols, but in GraphQL Vault it is included to the ecosystem. It's important. Other tools, GraphQL API Explorer. It's some kind of IDE for GraphQL schema, and GraphQL Playground is something you can play with your schema on. It's in cloud. Pros, flexible. It is flexible from request point of view, it is flexible from deploy point of view, and it is modern. Other paradigms came from at least 19th of 20th century, and this one is modern. This 21st century thing. It's not a standard, controversial. It's not a standard yet. It will. Finally, that's the future. I'm sorry. No streams. We need streams, but we don't have them, so we have to use polling from client to server. No way, this is an important thing, no way to return file from your GraphQL API. So you have to serve file somewhere else. It's extremely important to be careful with GraphQL requests, GraphQL schema. You can easily write in 5 strings. You can easily write the request which will bring your backend down. That's the biggest problem with GraphQL. And of course, if you will provide this, if it is a pub API, you will have not just bad formed queries, but evil format. How to survive? I don't know. It's why I didn't use GraphQL yet. I don't know how to write the backend the way I can handle the overloading. But look, I just see how it will be. One day, somebody will write a good, not today's JS frameworks, but the good JS framework for the browser. And this framework will use GraphQL as the only way to communicate with backend. And then we will step to the new shiny world with GraphQL the only thing we have to support with clients. That's it. So be prepared. How to survive? Important. You have to use some complexity analysis. There is no automatic tools to do it, but you have to do it yourself by your hand and brain to prevent your backend from exploding from some query. These 3 things you can use. You can limit the depth of the query. Not always helpful, but helpful sometime. You can use you can analyze your query cost by the weights of the fields you are requesting, and do not pass the queries too heavy. You think too heavy. This is not ideal tool, but anyway, it does exist. And query whitelisting, you can use special proxy between your resolvers and your real world to stop the queries you don't like. No more flexibility, no more freedom, so this is not the option, I guess. I'm sorry, guys, I have another 5, probably 7 minutes to talk. Is it okay? Looks like it is okay. So, how to survive? Data loaders, use them. Special thanks to Roman Sharkov, who helped me to prepare this part because it's the most important part of the speech. It's the future. Twirp, could you please raise your hand who heard about this protocol before? Okay. So, very simple thing. It is protobuf based on top of HTTP 1.1. It is used code gen. You can use JSON with Twirp, and this is what's the proper word? It is stitchless to switch between protobuf and JSON, because the server generated by this tool will support both protocol, both marshallers, and will differentiate them by content type. This code again. This self-documented as protofile is. So I don't know what for this protocol was created. Because it is not grpc. Okay, it was created to use protofiles with browser clients and do not use some other tools to some proxies between browser and grpc, something like this. Pros. This was created for Go backends. It is quite simple. It is HTTP 1.1, not HTTP 2. You can mix the code that Twirp generates can be mixed with other handlers for other URLs. So, and the number of JS clients available. It's not a standard. Up. Okay. No streams. And all the validators are on you. How to survive? No idea. I didn't use it, and I don't know what for I can use it. So, could you please raise your hands who know about Volcane protocol? That's good. Okay. Very interesting thing. It's server to build on top of a hypermedia API paradigm, which is quite interesting. Usually, then we provide answer, and this answer contains not just one object, but number of objects. We are providing the values for all the objects and fields in the answer. But hypermedia API, it's a different idea. You are providing the list of links to the objects, and then your client can query for these objects separately. Could this Volcane thing, it does exist, and it is production ready as far as I know. It could be used on top of traditional API. It is front-end oriented, and I will explain why it is front-end oriented a little bit later. And it is request response events, so you can send data from server to client, but you cannot send data from client to server. And it is JSON and HTTP2 and only HTTP2. This is only one diagram in my speech, which makes some sense. Very interesting thing behind this Volcane protocol. Then you send the request from client to server. Usually you're getting the whole answer, but not with Volcane protocol. With Volcane protocol, you are getting hypermedia answer. So the document with links to the parts of these documents have to be loaded later. But You don't need to request for these sub-documents. Server will start to push them to you using HTTP to streams. And why this is important? You can, some of them could be cached on your site, so you can interrupt the stream, the streaming, first of all. So it is cache-friendly, only cache-friendly protocol in the we are talking today. This also could be the number of streams controlled on server side, not on client side. So this is quite important. How to survive? Tools, I have no idea. I read about this, but I didn't use it. Pros, must be effective. I didn't test it, but still must be effective for caching and interrupting and channel using. GraphQL compatibility mode. Any GraphQL request could be what this word? Прозрачный. Transparent, yeah, right. So it is any GraphQL request could be transparently converted to Vulkan requests, so it is good. And also it could be used as a front end to Open API. Not standard and HTTP to bonded. And as you can see, this is very tight with HTTP2. How to survive? No idea. Didn't use it. This is a part I probably have to skip because I don't recommend you to use this protocol today. So we will skip it. We will skip it. We will skip it. We will skip it. Okay, right here, right now, use Open API. This is most you can build the system strictest way, really. And this is important. To communicate between servers, use grpc because of streams. For the future, be prepared, learn GraphQL. Okay, thank you.
Thank you, applause.
No time for questions?
No, we don't have time for questions. We can discuss it in the discuss area.
Thank you very much.
Thank you.